Average velocity is a vector quantity, and it's determined by taking the total displacement and dividing it by the total time. Nice thing about displacement is direction or changes of direction makes no difference. All that matters is where I started, which in this case is at the -3 mark. -3 meters is my starting point. And I end 24.5 seconds later at +9. That represents a displacement from -3 to 9 of 12 meters in the positive direction. So really, all I'm doing is final position minus initial position to get my overall displacement. And that took 24.5 seconds. And when I calculate the whole thing and round it off to the correct number of significant figures, I get 0.47 meters per second. And since my displacement is positive, my average velocity is positive. Now what about average speed? Average speed is the scalar version, and it's distance over time. And sometimes, even though it's a scalar, this might be more difficult to calculate. So if I look at my total distance traveled, I got to look at each section. So let me erase what I've got here. In the first region, I traveled from -3 all the way up to 6. So I've gone 9 meters here. I don't go any additional distance here, 0 meters when it's flat. And then I go from 6 to 12, I go another 6 meters. And then I go from 12 back to 9. Don't worry about the negatives with speed. That's another 3 meters. And when I add all those up, I got 9 meters plus 6, that's 15, plus another 3 is 18 meters is my total distance. And that took 24.5 seconds. So my average speed, when rounded off to the correct number of significant figures, is 0.73 meters per second. So notice if you change direction, your average speed and your average velocity are not the same magnitude. If this was all in one direction, then they would be the same magnitude.